The broadcast is now starting. All attendees are in listen-only mode.
Good afternoon, everybody. I think we have a topic that's going to be very interesting for many of you. It's about getting SQL Server set up right for the first time. And I'm Sharon Dooley. I'm going to be the moderator today. We'd like to thank our sponsor, Dell Software. They make it possible for us to have a raffle for an Amazon gift card. You'll be notified after the meeting if you're the winner. We are one of many virtual chapters. They keep growing. There are people who are presenting on different topics, usually something about every day. And if you're interested, you just go to SQL Pass and add your name to the virtual chapter, and you'll start getting mailings from that chapter. If you're not familiar with SQL Saturday, you should get familiar with SQL Saturday. It's a one-day free training event. It's always held on Saturdays, so you don't have to miss any work. You may be asked to pay for lunch, but you don't pay anything to go to the presentations. And they are conference quality presentations. And the only problem you're going to have is when there are two at the same time that you're going to want to see. I know in the one in Philadelphia, we usually have 6 tracks and 5 presentations in each track. So that's a lot of presentations in one day. And they cover the whole of SQL Server, business intelligence, as well as engine. And it's well worth looking. They're all over the world. They're not limited to the United States. This is just a short list of the near future ones. In May, PAS will hold its Business Analytics Conference, and it's going to be in San Jose, and there's a discount code. If you use the code BAVCDB, you can save $100 on the cost of attending these sessions. This is a virtual chapter with no physical presence, but we have many local chapters which give you an opportunity for face-to-face networking with people in your area. Excuse me. You can find out about the local chapters at the PAS website. And if there's not one in your area, you could consider starting one. PAS will help you. Just contact ce@sqlpass.org. PAS is an all-volunteer organization. Yes, there's paid staff and headquarters, but it's user-driven. It's a user-elected board of directors, and there are many different ways to volunteer. So you can just do it in your PAS profile. And if you're not a member, I urge you to become a member. It's free, and just go to sqlpass.org and sign up. Now, our speaker today is John Martin. He's a sales engineer for SQL Sentry, interacting with existing and prospective customers at conferences and trade shows. And he does demos and online webinars for existing and future users of SQL Sentry software. Prior to joining SQL Sentry, John worked as a premier field engineer for Microsoft based in the UK, and worked with a wide variety of customers in many different industries, that make use of SQL Server and the Microsoft Azure platform. John's been working with SQL Server for the last decade and has a broad understanding of how you can use and misuse SQL Server, and I'm delighted that he's going to share his expertise with us today. And so I'm going to make him a presenter as soon as PowerPoint cooperates with me and turn the meeting over to him.
Okay, thank you very much.
And now your show my screen button should brighten.
Yep, and we should now be able to see the slide deck. Can you see that all right?
I can see it, yeah, it's fine.
Perfect. Okay, not a problem then. Cool, well, thanks very much for having me. Appreciate your time. So, there we go. Right, what I'm going to do is start moving the slides on. Just before we begin, over at SQL Sentry, we've got a whole pile of free resources. We've got 5 free ebooks you can get hold of. Just go to SQLsentry.com, get the free ebooks. They're proper content, like Paul Randall, Paul White, Jonathan Caius, Kimberly Tripp, all contributors, and it's a couple of hundred pages of good content we're giving away for free, so feel free to go on over. As I said, I work for SQL Sentry. We do monitoring tools. If you're interested, drop me a line. Some information about me. As already been said, I'm a sales engineer over for SQL Sentry, working with SQL Server for the best part of 10 years, longer now, really. Dev, DBA, BI developer, and prior to joining Sentry, working as a consultant for Microsoft over in the UK and Europe. So lots of experience of going out and seeing how people are using the systems. And this slide deck is really sort of in response to some of the things I encountered. Many of the things I encountered, probably, better put. It's people consistently don't do the fundamentals right. So if you can glean some information from this, just 1 or 2 little things. I mean, I'm not saying everybody sets their systems up terribly. It's always a case of there's 1 or 2 things that are always missed in my experience. My contact information is there. Feel free to drop me an email. I'm happy to discuss anything you see here on the deck, or as we discussed through the course of this. Got a blog there. Post random stuff about SQL Server. Doing a lot on security, virtualization, high availability at the moment. Feel free to stalk me on Twitter or LinkedIn. Not a problem. So, as I said, this deck is primarily in response to a lot of the stuff that I saw out in the field when I was working for Microsoft. And we're going to just basically step through all of the key stages for setting up and deploying SQL Server effectively. We're going to focus in on getting the core generic framework and foundation in place first. So we're not going to look at any sort of specialist configurations around fast-track data warehouse, OLTP. We'll start with a good foundation, get the foundation right. You can build it and make it a lot stronger from there on out, and you'll get your system where you need it to be. So the first thing you need to do, deploying any form of SQL Server, be it a single box to a farm of SQL servers supporting a large ERP system, is to have a good plan. Essentially understand what are you going to be deploying the system for. Understand where all your resources are, understand who's going to have access, all that sort of stuff. Having a good plan, even if it is just a predefined document that says, this is what we're going to be doing, and this is our standard build document, that's great. All the way through to tens of pages for high-level, low-level designs, like I say, supporting those large implementations. But the key components you should have in any plan, it all comes down to starting off with capacity planning. If you don't do the basics of capacity planning from the outset, then it's going to be in a position that you may not scale the system properly, understanding what you're bringing into it, if it's going to be upgrades, if you're deploying new systems, that sort of things, just making sure that what you're deploying onto it is going to work. So having a good core capacity planning element to any plan is going to be essential. Can range from, if you've got monitoring tools, looking at the historical analysis, all the way through to, if you've got nothing, actually looking at the scheme of the database and trying to discern that. And we'll cover that as we go through. Once you've understand what the capacity requirements of the system are, then it's important to start looking at, okay, well, what is the use case going to be? Again, when you think about, is it going to be data warehousing? Is it going to be OLTP? Is it going to be virtual? Is it going to be physical? All that sort of stuff. You need to understand why. What are we putting this together for? Because you're going to have different requirements underneath SQL Server from the storage capacity side of things. When you think, we're going to put a data warehouse together, many terabytes potentially of storage versus an OLTP system, it's going to be relatively quite a small storage footprint, and the way that it's going to be accessing data and what have you. So understanding that is going to feed into your plan and when you're going to put things together. Now, if you're going to use the cloud or on-premises, when I say cloud here, I'm referring effectively to off-premises, out of your control, rather than virtualize or something like that, private cloud, public cloud. We'll discuss virtualization in a bit, but understanding whether or not you're going to be using a cloud provider, so you're going to use AWS, Amazon, Azure, OpenStack, all that sort of stuff. Who's going to be hosting it? Where's it going to be hosted? Again, that can have an impact around the way you configure the security side of things. So again, understanding that and building that into part of the plan. You've got to understand your high availability and disaster recovery requirements. What is the uptime? Is it Monday to Friday 9 to 5? Is it 24/7? Have you got 5 minutes that you've got to have the system up and running again in, or have you got a day? Things like that. Understanding where you need to be, again, fills into the plan. Then we look at physical or virtual. Now, majority of systems these days I'm encountering are virtual or going virtual. Now, that used to be an issue. It's not really an issue now. The vast majority of SQL Server workloads can very, very easily be virtualized. Excuse me. Some take a bit more thought. Some you're just not going to get there with. So understanding, again, what your use case is, if it's going to be on premises, and then is it a physical or virtual, you can see the interrelationship now between these categories that we're looking at and bringing into our plan. Physical versus virtual as well, you've got to think about from a scalability perspective. Virtual, it's a lot easier to scale up an environment, so you can add more vCPUs, you can oversubscribe them, you can add in additional storage, you can add in additional memory, an awful lot easier than if it's a sort of physical server in a rack somewhere, typically. Some of the configurations I've seen with virtual environments, they go one-to-one with host and OS, and it's just really to make sure it's transportable for the guest, so you can take it from one VM host to a larger one and then upscale it again. So understand that can have a big impact on the way that how you're going to have to spec the equipment that you're going to be running on. And then really understanding the versions and additions that you need to use. What's the feature set? Again, comes back to what is the use case. Understanding, do you need Enterprise Edition, do you need Standard Edition, BI Edition, what are you looking to do, what are you looking to achieve, how many users, how are people connecting? So is it going to be sort of an internet-facing application backed by SQL Server, in which case you really need to look at your core-based licensing with something like Enterprise or Standard Edition, versus, okay, it's going to be a finite number of users internally, so maybe we want to go server and cal with BI Edition. All that sort of stuff, so understand what it is. Are you going to be using 2012, 2014? Are you already starting to look at 2016? Things like that as well. So to making sure that you understand what that is. And also when I say versions, I mean build versions, the build numbers. Try to standardize them across as well, the environment that you're working with. Excuse me. So is your have you got sort of 2 or 3 different cumulative update versions that you're using throughout your environment, or is it more? Try to restrict it. It just means that you've got consistency. Consistency, I find, is a very, very good thing when it comes to managing a SQL Server estate. You know that everything is going to behave the same way. Okay, so we start off, we get a plan. Like I say, it can be a simple, this is how we build a SQL Server document, all the way through to something much, much larger. Now, when we think about the capacity planning element of it, The three main areas that, in my experience, can hurt SQL Server the most if you don't get them right is storage, memory, and CPU. Not included network on there because, as I'm sure we're all well aware, it's never the network's fault. But anyway, the storage side of things can really hurt you if you get that badly wrong. So really, in order to understand, okay, what do I need, we need to look at what we've been doing. So if this is going to be an upgrade, what we need to think about again is, okay, have we got any metrics that we can look at for a period of time? How long has this source system been alive for? What's its growth profile been over the last X number of years if it's been there for that period of time? So you want to understand how much storage is it consumed, not only from a capacity footprint, but then also from an IOPS footprint and your throughput as well. Okay, how have these varied over time? Have they grown? Have they plateaued? Have they been pretty flat? Are they spiking? Are they peaking at certain times of the year? All that sort of stuff. Okay, and then if you don't have that information, what can we do to get it? Well, there is the map tool from Microsoft, which is a free download, which you can have to analyze your environment if you've got an existing system to audit. Alternatively, start looking at the database schema itself. If it's something like a sales system, then understand, okay, well, the key table is going to be my order tables. Okay, so they're going to have an order date column on them. So start drilling in, okay, what are my order rates per month? Okay, you know how many orders you're taking, you know how wide the table is, you know the data types. You can start extrapolating information from there, and you can start looking back and say, okay, well, we've been growing by X percentage year on year, things like that. So you can take that information. Then we can take it and we can project the use. Now, if you haven't got a history, if this is a new system that you're implementing, you can only really start looking at projecting. Now, this is where working with the vendor, or so if it's an off-the-shelf package, SAP, SharePoint, things like that, understand, okay, well, if I've got 1,000 customers and I take 10,000 orders, what is the footprint? Okay, that type of thing. Understand what the workload is and then work from there. Now, if you're doing anything like this, it's really important that you basically look at documenting your assumptions. If you don't document your assumptions, anyone coming in behind you, why was this decision made? I haven't got information around this to base a decision on. Okay, I made this assumption because of X, Y, and Z, and then anybody reading the plan afterwards or understanding it has got that information to hand. Makes life a lot easier. But projecting the use then allows you to look at moving on and saying, okay, from a scalability perspective, well, we're going to start small and make it larger as we go through because we're going to run on a virtualized platform and we can do that. Or if you're using something like Microsoft Azure, you can say, well, we're going to start off on an A4 and then we're going to go up to a D6 class virtual machine, things like that. Or you're going to start off on a smaller service tier and then move up. So you can do that. If you're going something like physical, then you'd say, well, we're not going to have the chance because in 3 years' time, we might not be able to buy more processors or more memory on the open market. We need to scale the system for its total capacity in 3 years' time at the outset. Understand how that's going to work. Okay. So once we've got all of that information to hand, we can start looking at what I term the pre-deployment phase. And this is where we start looking at our overall infrastructure configuration. So we're starting we're not going to deploy SQL Server yet, we're going to rely on the system guys to get things right. With regards to our infrastructure, the key thing here, if we're working with any form of physical hardware, we want to understand our drivers and firmware. Storage, we want to make sure we've got good multi-pathing. And again, how's the storage configured underneath? Am I on the same SAN as, say, Exchange and SharePoint and a whole raft of other things? Have I got it to myself? Is it local storage? Am I using availability groups and clustering and things like that, and how are we interleaved with other portions of the overall solution? So understanding that's going to be very important. On the drivers and firmware front, if you're deploying physical servers still, very, very important to understand what the supported options are there. Now, I have seen in production where there was a mismatch between drivers and firmware on storage controllers. In that situation, it resulted in several terabytes worth of corruption on the storage platform. Even after using the sort of restoring from backup, there was still nigh on a terabyte of absolute data loss, and that was document level objects, so Word documents Excel documents, PowerPoint, you name it, that type of thing. That's a lot of information to lose just simply because the driver and firmwares didn't line up. Again, correct multipathing. I've seen very, very high spec solid-state flash SANs being absolutely hobbled just because basically the nodes communicating with them just couldn't talk to it. They had one channel as opposed to the four that they were available to them. So getting it set up right, very, very important. Now we want to make sure that we're up and running first. Testing and validating the underlying infrastructure is going to be key. Even if this is virtual, we want to really soak test it and we want to stress test it. From a soak testing perspective, we're just going to sit it there and we're going to run it for a long period of time. And we're going to try and find, in normal operation, does it fall over? Have we got a dodgy processor? Have we got some bad RAM? Have we got issues in any of the hardware we've got there? You can buy third-party software for it, things like Burn-In Pro. One person and customer that I actually spoke to used SETI. So they'd rack their servers, they would then just set them up and then run SETI on them for a month and then tear them down, completely rebuild them from scratch, and then bring them into their infrastructure. They were happy that it was taking a workload. And then there's also stress testing. You're basically going to push it to within an inch of its life and see if it's going to fall over. You want it to fall over before you take it into production. Now, if you're adding to sort of virtual servers to an existing setup, you can be pretty confident that the environment is going to be running. If it's been there and it's running without a problem for a long period of time, a lot of that's taken care of, and you just have to start worrying about your actually deployment phase and so on and so forth. So, after pre-deployment comes deployment. Now, this is, if you don't get this bit right, your system's going to be toast, really. Standardise is a keyword here. What we want to look at is basically having a small number of versions available to us. Now, this is where I said that you don't really want to be running 2005, 2008, 2008 R2, 2012, 2014, and then any number of service pack revisions of each of those, and then cumulative update revisions of those as well. So the days of, well, we installed it with this and then we're never touching it again because something might happen, they're gone. The cumulative updates of service packs do go through a lot of testing, and you can be pretty confident that they're there to actually remediate issues and solve a lot of problems. So what I tend to try and do when it comes to deploying systems is to maintain, okay, well, we're going to be looking at standardizing on 2012, 2014, for example, service pack X, cumulative update Y. So putting all of that information, all of those binaries into one physical location that's available to anyone who needs it on the network as well is going to be key. If you do that, it makes life a lot easier. I have encountered scenarios where, okay, I've gone to a customer, SQL Server stopped working. Why? Why has it stopped working? The reason being they simply downloaded and installed the eval edition because someone didn't have the right bits to hand when they did that. So these things do happen. I've seen MSDN in production as well. And they're just not great situations to have to work back from. So if you've got a small number of defined versions that you're going to be using for SQL Server, and they're available in one location, so you know that when I do a build, this is where the binaries are, that's what we're going to use. That's great. Standardizing on your operating system as well is very, very important. Try to go for the highest you can. I have seen SQL Server 2014 deployed on top of 2008 R2 OS. Not really the best scenario when you look at the life cycles involved for all of these. So what you really want to try and do is say, okay, I'm going to get the operating system that's going to have the longest life cycle of all, because trying to upgrade that is going to be a nightmare. Okay, so start off by sort of standardizing on the highest operating system you can and bring systems up as you migrate and upgrade systems throughout the course of their life cycles. Automating as well. If you're currently sat there working through the wizard going next, 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 and putting the information in by hand, stop. At most, do it once, create a configuration file, use the configuration file if you have to use the installer. Anything that's going to remove the need to type anything in means you're going to make less mistakes. And mistakes get made. Typically, a lot of places I've worked, people who get stuck with the builds are the junior DBAs. Not the most experienced, they're here to learn, and just, well, the senior DBA wants to get on performance shielding, doesn't want to do the build. Give it to the little guy. You take people out of the loop, you end up with people being more interested, more invested, but also you end up with less issues. Now, you can use sysprep with SQL Server, so you create yourself an image. If you do that, then you've got to think about, okay, how am I updating this image with regards to things like the Windows updates, service packs, cumulative updates, all of that sort of information as well. How are we working with that? Configuration files, great if you want to do it from the command line. Work it in with PowerShell as well, so you can pass in parameters to a PowerShell script, have it update the configuration file, feed that into the installer as well. So that way you're not hard coding in usernames, passwords, and so on and so forth. Drive letters, various storage paths, all that sort of stuff. If you can parameterize it, pass it in, that's great. The Spade framework is an open source framework for automating the installation of SQL Server via PowerShell. It's available at sqlspade.codeplex.com. Really, really useful, really, really powerful, can make your life a lot easier. Well worth looking at investing the time to get that set up if you're building SQL servers on a regular basis. In addition to that, there's also an option now that's starting to gain some traction now is PowerShell DSC, desired state configuration. There's a GitHub project around SQL Server and facilitating that. It's not quite there yet, but well worth keeping an eye on and starting to understand the concepts behind DSC should make life a lot easier when it comes to doing large-scale repeatable deployments. Okay, so that way you standardized everything. You don't have to manually go in and do this. You're going to have less issues. You'd be confident that you can press a button or fire off a script, and you're going to end up with the same thing coming out every time. Now, when we start thinking about service accounts, one of the key things here is compartmentalize. Now, in this scenario, what I'm saying is use a different service account for each service and server. So try to avoid having one common service account for the whole SQL Server estate. Try avoiding, especially when it comes to SQL Server Agent. Now, typically looking at domain accounts, very, very important to think about this. What resources am I going to be accessing? How am I going to be granting permissions to them? One of the other things we want to think about as well when we think about setting up these accounts is, okay, well, if this account gets compromised, what's the scope of that compromise? Because they're accounts, they're going to be passwords. They're going to be complex passwords, which means we're going to have to write them down somewhere. Are they going to be on a piece of paper in the safe? Are they going to be, please, not in a password-protected Excel spreadsheet? Or are they going to be in a proper password safe repository software system, things like that. You try and avoid having the same password across all of them so people can remember it, stuff like that. The reason I say this is because if you think about, okay, the SQL Server service just needs to have the permissions in order to run the SQL Server service. Nice and easy. SQL Server Agent is a sysadmin in the context of the SQL Server instance that it runs in. Now, I have seen in production an estate with over 130 servers using the same service account for SQL Server and SQL Server Agent. What that means is one account being compromised, which means potentially the entire SQL Server estate is then wide open to whoever has that password at sysadmin level. Okay, thank goodness they didn't actually have it set as local administrator or domain administrator as well, which are other things I have seen. So basically work on the principle of least privilege. Only grant accounts what they need in order to run and compartmentalize and decouple the environment as much as possible. Now, if you're using SQL Server 2012 and above, we have the option of looking at what we term managed service accounts. Managed service accounts are account entities you create in Active Directory. Essentially, you bind the computer account in Active Directory to the managed service account. Now, what that means is when the so you configure SQL Server service and you give it the identity of this managed service account. The server will then go to Active Directory to retrieve the password, essentially, which means you don't have a password to write down. You don't need to know it because you've established a link between the computer account and that managed service account entity. Now, in that scenario, what it means is that if you've got to do password rotations, you can just set the managed service account up to automatically rotate its password. It's one of the parameters you can use when you create them. Managed service accounts are created using PowerShell scripts. There's no facility to do it through the UI, but once you've created them, you say create this account. Okay, it's going to be valid. Rotate the password every 45 days, and then automatically in the background, it's going to rotate it, and the server will negotiate with Active Directory to retrieve the password, and so on and so forth. Makes life a lot easier in that regard. Prevents people from being able to log in with those accounts. Okay. Now, managed service accounts are supported for SQL Server 2012 and 2014. Now, that's great unless you're running things like always-on availability groups or failover cluster instances where you need to have the same identity on a number of servers. Okay. In that scenario, you're going to have to fall back to the traditional domain service account, if you will. SQL Server 2016 is going to change that. SQL Server 2016 is going to allow the use of group managed service accounts. Now, what this means is that you create your managed service account in Active Directory, then you create a security group and put the computer accounts into the security group. Link the security group to the managed service accounts, basically saying this collection of servers is allowed to interact with Active Directory in relation to this service account. So now you can have multiple servers with the same service with the same identity, and have all of the benefits of the auto password rotation, no password stored in password manager, all that sort of stuff, enhancing the security of the service account setup that you work with SQL Server. So I'd seriously say if you're looking at SQL Server 2012 and above, have a look at managed service accounts. Obviously, if you're using availability groups or if you're using failover cluster instances, then you're stuck with the more traditional account. If you're going to go for SQL Server 2016, managed service accounts, group managed service accounts are where you should really be looking for running your services, in my view. So once we've got SQL Server installed, we've got the service running, what do we need to set up? First and foremost, we want to look at setting some trace flags, so startup parameters for SQL Server. The key ones here that I would look to put on every SQL Server are 1117, 1118, and 3226. Now, 1117 and 1118 are really aimed at helping alleviate potential Temp DB contention, and also managing and maintaining file growth, where you've got multiple files in a file group. Okay. So 1117, if you've got multiple files in a file group, as you typically do in Temp DB, and you should really be looking to do if you're running multiple files in your user databases. In the event of the files filling up, the normal behavior of SQL Server is to grow one file, then the next one, then the next one, then the next one, as each one fills subsequently. 1117 means you hit the file limit, it's full, all files grow at the same time. Now that does rely on you having the same file size from the outset and auto growth increments. Now if you're proactively managing your file growth, that's less of an issue, which is obviously where it's aimed at Temp DB, because sometimes you've got a query that runs amok and blows your Temp DB out. 1118 switches over to using dedicated extent allocation. So again, this can alleviate issues where you're creating and disposing an awful lot of temporary objects, and you're hitting things like the PFS pages, GAMs, SGAMs, and such like in Temp DB. So we've gone for multiple files, so we've got more of those pages. Dedicated extents, again, helps lighten the load, essentially. It will have an impact on user databases as well. Now, with 2016, that's been enhanced. That behavior has become native behavior, and there's obviously configuration options around that now with things like database scope configurations. But that's, if Microsoft feels so strongly that they're baking that in to the core code, again, it should really be something you're looking at from the outset when you start building your SQL servers. 3226 is one of my personal favorites if you've got a large number of databases on a server. When you're running frequent backups, so you run potentially a daily full and then transaction log backups for databases every 15 minutes or so, once you start getting up into the tens of databases, you can start ending up with a lot of information messages in your log. Backup succeeded. That's great, thanks. I'm really interested if the backup fails. I'm not so interested if it succeeds. 3226 will stop the success messages dropping into your SQL logs. So if you're doing proper log rotation, what it means is when you come to try and troubleshoot that and you look in the SQL error log, you'll be able to try and find that information a little bit quicker. You'll still get the messages around it failing for backups, but turning that on, again, it can remove a lot of noise from your SQL Server error logs, so well worth considering. Okay. Those are, like I say, the trace flags I'd look to deploy by default. Trace flags around things like the back off of statistics threshold. So normally it's 20% plus 500 to get an auto stats rebuild. There is a trace flag that will back that off the larger a table gets. I would only really look at putting that in place in the scenario where I'm going to be dealing with very large tables and such like. Again, it is one of those things. It's got a scenario, a defined scenario that is a subset of what you're managing. These ones here, you're typically looking at, okay, I should apply for just about everything. Where you're dealing with a smaller subset, again, think about it before you make that decision. Don't just apply it globally across your estate. It may be appropriate, it may not be appropriate. Then we start coming in and looking, okay, well, we've got our SP configure options. Which ones are the ones we want to look at here? Backup checksum default. Now, we should all be running checksum page verification on our databases, which means that in theory, every page should have a checksum. We want to validate that at backup. So when you do your backup database, whatever, to disk with checksum, what you're looking to do is validate that checksum as it writes the backup. What this can essentially help you try and do is prevent corruption getting into your backups. Now, if you've got torn page or sort of, in a really worst case, no page verification set, simply turning checksum on won't give you the checksum on all the pages. You've got to effectively lift them from disk, change them, and write them down. That will put the checksum in there. So it can take a while to bed in if you've got an existing database that you're turning that on and subsequently bringing that into the fold, if you will. So even with that enabled, you may end up with potential corruption in there if the page hasn't got a checksum. Backup compression on by default. You'll get systems guys saying, oh no, we do compression, we do dedupe, we do this, that, and the next thing. That's fine. I want my SQL Server backups to complete as quickly as I can have them complete. If I've got compression turned on, it means I've got less data being written out of my SQL Server process. Less data being written means higher performance on your backups, so you're writing smaller files. That's typically where a lot of the bottleneck is. Yes, it does put a small CPU overhead on there, but not one that I've encountered that can cause a major issue. Obviously, if you are CPU bound, test it, check it. Okay. Max degree of parallelism. This is a contentious one. A lot of people I've met say, no, I'm going to leave it at 0 and let SQL Server figure it out. It knows what it's doing. Others said I'm going to set it to 1 because I've read something on the internet, or I'm running SharePoint or another of the Microsoft stack that mandates that it must be 1. Current thinking is the number of physical cores in a socket, a NUMA node, if you will. So just to understand what that means, if we look here, we've got 2 sockets, we've got 2 NUMA nodes essentially. Each socket has its own bank of memory. There's no guarantee that you're not going to be able to get local memory all the time, but what you're trying to do and really sort of looking to try and achieve here with a configuration of setting it to the number of physical cores in a socket is so that you don't have to do synchronization between the sockets. If you're doing that, it's going to take a couple of compute cycles. If you're doing lots and lots of rows and lots of synchronization, they'll soon add up. So just work with that. I mean, there is a very comprehensive Microsoft KB article around what the recommended configurations are. Now, they are just that. Obviously, if you've got an edge case scenario or a specific scenario where it's going to be a high concurrency OLTP system, you may want to look at changing that. Just find the sweet point, but it's a good place to start. Min and max server memory. Again, I've met people, no, we just leave these well alone and SQL Server will balance itself out against whatever else it's finding in the system. Yes and no. I'm a firm believer that a max server memory setting will give you a level of stability in your environment, so long as you set it in such a way that you've got sufficient free space for anything else that's running on that box, and you should end up then with less conflict. Min server memory is a guaranteed level of performance as well when it comes to SQL Server. That way you're not going to shrink way down. So if you've got quarter of a terabyte of RAM in your server and you've set the max server memory at 200 gig, if something for some reason runs away and you've not set a min, then you could lose all of that at any given point in time. So if you set a minimum server memory, then you can say, well, I'm going to try and guarantee myself that I'm going to have at least 100 gigs the SQL Server is going to use. We may end up then with an instability in the environment if something else is trying to consume huge quantities more memory, but I want to try and protect SQL Server as best I can. Optimize for ad hoc workloads. Turn this on by default on all my SQL servers that I managed. I never encountered an issue with it. If anything, the scenarios where it's not been turned on and I've had a large amount of plan cache bloat, so lots of single-use plans, optimize for ad hoc workloads can reduce, I mean, in certain scenarios I've seen, looking at, I think the biggest saving I made was 6 gigabytes of memory. Turn that on, 6 gigs of memory, effectively we got back into the buffer pool essentially, because we just weren't using it for the plan cache. Lots and lots of single-use plans due to vast quantities of dynamic SQL coming in from the application. So well worth having a look at there. Remote admin connections as well. I turn this one on. Obviously, you've got the DAC. If you can get on locally, great. If you can't get on locally or you can't get the console, but you can get remote connection with the DAC, that makes life a little bit easier. Saves you having to try and potentially get console access or something like that if you don't have it. It's just another get out of jail free card. Turn it on. When it comes to XP command shell, this is where my inner DBA comes out. It depends. I would much rather it was not there, but I know there's an awful lot of legacy systems out there that use it. If you have to, yeah, it's going to have to be on, but I'd say try and find another mechanism for doing what needs to be done with it. Is it a process that needs to be built into an application? Is it a batch job that would be better served with it done in an agent job, done in integration services, something like that? Understand what's using command shell and then back off from using it. Then we look at some of our security configuration. If you can, avoid using SQL authentication where you can, but again, I appreciate there's an awful lot of applications out there that might not necessarily be comfortable using Windows authentication that still require usernames and passwords and SQL authentication. Disabling and renaming SA, again, it's just another attack vector that you're making it a little bit more difficult for people to try and get in there if needs be. Proxies, agent jobs, so rather than having agent jobs execute in the context of the SQL Server agent service account all the time, install credentials, set up some credentials, so look at what the process is. Understand, okay, well this job or this batch process needs to access these file resources, these databases, and then it needs to put a file somewhere, for example. Okay, so you create a Windows level account, add it as a credential, and then you create the appropriate proxies in SQL Agent that allow you to use those subsystems. So if it's doing manipulation with PowerShell, command exec, integration services, all that sort of stuff, and then run them in the context of those. So you'd have multiple proxies and multiple credentials and build it around the processes. Don't go overboard and have one credential for every single step, because then it becomes very, very difficult to manage. So use a bit of thought there, but typically look at what the process is, what you're trying to achieve. By using that, again, what you see there is the ability to turn around and say, okay, well, SQL Server Agent then has a very limited footprint for permissions within your environment. So when it comes to migrating servers as well, you can be pretty confident that if you've got the credentials and your proxies configured appropriately, that you're not going to have to go and trawl through the network looking for, okay, well, SQL Server Agent runs this. Well, what are we actually, what resources are we actually getting? So you've got to go and find all the permissions and everything like that. Okay, well, we're going to have to just move and use the same service account for SQL Agent on the new box, or things like that. It can be a bit more hit and miss. And if you're moving those processes between servers as well, it just makes life easier. You create the credentials on the new server, create the proxies again, everything should tick over quite well. Perform volume maintenance tasks as well is a server level security permission, which helps facilitate instant file initialization, which can have quite a dramatic impact on file growths, so data file growths, be they managed or auto grows, backups and restore processes and things like that as well, can help make life a little bit easier. Okay. Now, when it comes to lock pages in memory, it's a bit of a contentious one. I know people that turn it on for every single server. I tend to not do that personally. For tier 1 systems where you can't afford the downtime, or you really want to protect the buffer pool, yeah, turn it on. Just make sure you've got checks and balances in place to try and identify whether or not you're going to have any memory-bound issues. For tier 2 systems, if I can take the downtime, I can take a small outage. What I'll typically do is say, no, I'm going to turn it off. I'm going to leave it off. When I hit the issue, then I want to try and do a root cause analysis, and if it's going to take me a while to get the fix, I'll maybe switch it on, protect the buffer pool, get the fix, deploy the fix, then turn it off again. I'd rather have a system that I know is healthy than one that is potentially having some masked underlying issues. Now, when it comes to configuring Temp DB, we're talking multiple files. At the moment, current best thinking is equal to the number of cores that you've got presented to SQL Server up to a maximum of 8 to start with. Then go from there. Do you want to bring it down? Do you want to take it up? It should really be driven by the amount of, or whether or not you're seeing contention in your Temp DB. If you think about it, if you just turn around and said, okay, well, I've got 128 cores and I'm just going to create one file for every core, that's, again, it becomes unmanageable. So you need to be quite pragmatic in this one. Start off with a maximum of 8 and then work from there based around whether or not you're seeing contention. I've encountered environments where you've got a single data file and there has been no Temp DB contention. There's been virtually no Temp DB utilization. So multiple files would not have benefited in that scenario. Other environments where they've had too few files and then, okay, we need to add more. Okay, now we found the sweet spot. Now it's working fine. I try to put Temp DB out on dedicated storage as well, away from your normal user databases. Now, obviously, if you're working on a shared storage platform, a large SAN or things like that, you're potentially going to end up with that level of contention. Now, with that environment, whether it be virtual or dedicated physical hosts that are connected to the SAN, the big question you want to ask yourself is, do I have enough aggregated I/O capability to service my workload? That's the key metric here. If you don't, then you need to figure out how you're going to try and get that. Have we got another storage platform we can put Temp DB into or something like that? Okay. Now, some of these large storage environments, yeah, you've got many thousands of IOPS, huge amounts of storage throughput. A lot of it can handle it. In which case, what you're doing here, when you think about, okay, I'm going to create their own small VMDK files, VHDXs, or smaller LUNs and dedicate them in that way, it comes down to a management perspective for you. It's easier to ask a sysadmin to pin SAN admin to pin a smaller LUN into the flash tier of an array than to say, okay, well, I've got everything in a 4 terabyte LUN and I want Temp DB in flash. Things like that. So it moves away from the performance side of things to more about the manageability. And then we've got the best practice of just separating data and log files. Again, different I/O workloads, different patterns. Again, when it comes down to the management of, well, I want this in flash, I don't want that in flash, that can go on slower disk or faster disk, things like that. Segregation gives you that level of management still. When we think about our database configurations, again, we're looking at instant file initialization, which takes us back to looking at the perform volume maintenance tasks. We really want to try and have that for our databases. It makes those file growths a lot easier when it comes to growing data files. If we can, we want to look at multiple files and file groups. If you've got control over the database schema, you've got your primary file group, create a new file group, designate that as default, and then if you have got to get a large database or you want to start leveraging things like piecemeal restore, you've got that option when it comes to enterprise edition and what have you. Also, it means you can spread them out if needs be onto different storage tiers and so on and so forth. So you've got files and file groups that you can use. I have encountered environments where there's been a single multi-terabyte MDF file. Not really the best thing in the world for working on. Separating data and log, again, they're two different workload patterns, but also comes down to manageability. We may be on the same underlying storage subsystem, but it means, again, that we've got that versatility when it comes to, well, I need to grow this particular LUN by X amount, and I want this one in Flash, and so on and so forth. As I mentioned earlier as well, checksum page verification. If you've got that on from the outset, you're going to be in a much stronger position for trying to detect and identify corruption in a system. There's no way to prevent corruption. You can only detect it. The earlier you do so, the better you're going to be from a position perspective. And setting the appropriate database owner. Recently, the SQL Skills team did a demonstration. If you've got trustworthy turned on and your database owner is SA, you can get privilege escalation attacks. So well worth checking out the video that was there for those. But if you don't get it right, again, it's just another potential issue that's going to hurt you further down the line. So if you have got to look at using the trustworthy bit, low privilege accounts where possible for database ownership. Then we think about maintenance operations that we're running, things that we should be running, check DB. Run it as often as you can. I'm not going to turn around and say you need to run it every day, you should run it every week, you should run it every month, as often as you can. Quite simply, and if it means that you've got to take obviously your regular backups, take one of those regular backups and restore it somewhere and then run check DB on it because you can't take that workload hit on your primary, so be it. It is a representative test, and obviously if you get a corruption on that one, restore the backup, rerun check DB. I have encountered issues in the past where the restored database has had corruption and the source hasn't because it was a dodgy IO storage subsystem on the system that I was using to test my backups and restores and check DB on. So don't sort of fly off the handle straight off the bat, just double check that it is likely to be corruption or not. We want our reindexing and stats maintenance jobs so that we're effectively doing that. I'm still a firm believer that we do need to reindex things. Fragmentation can adversely impact performance in my experience. Statistics maintenance as well. So yeah, if stats are getting out of date or you've got skewed stats, you may want to look at how you refresh those, how you build those statistics. Do you need to add some custom stats, that type of thing. Log rotation. Now when I say log rotation, I'm talking about the SQL Server error log. Increase the number of them and then rotate them as often as required in order to make sure they're not too large. When it comes to trying to troubleshoot what's going on and pulling information out of those error logs, the smaller they are, the more responsive it's going to be to your PowerShell, or if you've got to use the log reader or things like that. And monitoring suspect pages in MSDB. Again, I'm a very firm believer that this should be something that's on every single system, be it an agent job that sends you an email, anything like that, in addition to setting up the agent alerts, that type of thing. Suspect pages will give you, again, an early indication as to whether or not you've got some potential corruption in there. And if you're using availability groups or mirroring an enterprise edition, the automatic page repair function that encounters there, or is part of those features, can mask potential corruption, because if you've got a corruption in a data page, an index page, it will go off and it will try and retrieve a good one from one of the replicas and repair the primary or whichever one it's got the detected corruption on. Now, what that means is if you're monitoring suspect pages, you can actually look for an increase in the count of fixed pages, so you can get an early indication that something's not right and then start looking at it in a bit more depth. Like I say, detecting corruption as early as possible, very, very key. So finally, the monitoring and alerting, obviously a subject quite close to my heart. Monitoring your key performance counters. You want to monitor your CPU, your memory, your I/O. You want to look at your key throughput metrics. So am I looking at storage throughput? Am I looking at transactions per second? Am I looking at batches per second? What am I looking for? Log flushes per second. All of this stuff that's going to tell you how healthy your system is and will give you an indication of when it's not healthy. But also, coming back to the very first thing that we talked about was capacity planning. What do you need to track in order so that over the life cycle of this system, when it comes to upgrading it to the next version, what am I going to need to know about when I get there? So we've got our key performance counters. Baselines as well we want to generate. So we generate our baselines. That way we can go back and compare them. So we can say, okay, this process 2 months ago took up these resources, took this long. Today it's taking longer, it's taking 5% more. Okay, based around that, we can say in a year and a half's time, we're going to need a bigger server, or we're going to need to do something in the short term to deal with that. SQL agent alerts can make your life a lot easier. Again, you can get SQL Server to send you an email if it's got issues around, it's detecting something like an 823, 824, 825 errors, storage issues. You get it to send you emails when you get conditions that are a certain severity of say 18 and above. You can say, okay, if I get 18 and above, send me an email. That way you're getting information early about what's going on. And finally, I'd say have a look at policy-based management as well. Once you've got your server configured, you want to make sure it stays configured the right way. Policy-based management can work with that. It's normally by server. Again, if you go to Codeplex, you've got the EPM framework, which will give you more of a centralized view. It's built and managed and run by the community, and very, very useful to look at. If you implement it right, it can save you an awful lot when it comes to doing your morning checks. Or if SQL Server is misconfigured, you can get it to revert that configuration to how you want it, or just send you an email, notify you that there's an issue you need to remediate. So we've rattled through this quite quick. Have we got any questions?
Oh, do we have questions?
Uh-oh.
It's okay. Could you provide the location one more time where the PowerShell scripts are available for automating SQL Server installs?
Yeah, it's SQL Spade, sqlspade.codeplex.com.
Is using NT Service /MS SQL Server as the account name for MS SQL Server good or bad?
So using a built-in account. It depends. I mean, my personal preference is to use domain accounts where possible. There is a KB article that will help that Microsoft have published that you can walk through and say, okay, well, in my given scenario, I might want to look at using a specific service account. What I'll do is I'll make the deck available to you to email out to the guys, and I've got all the notes and slides as well with the KB articles and stuff like that.
Okay, if you send that to me, I can post it.
Yep, we'll do.
On our website.
So yeah, I mean, I've got all the KB articles in the notes fields.
Great. I think this question is, how about SQL Server 2008 R2 with Windows Server 2008 R2? Should a managed service account work?
It might work, but it's not a supported configuration.
In terms of appropriate database ownership, do you recommend using SA or a domain account?
I would not use SA. It depends. You can do a very low privileged domain account. You could just create a low privileged SQL Server account. A lot of it around the appropriate database ownership comes down to really a case of just try to avoid giving something that's got sysadmin privileges. There's various different options available, and it just depends a lot on your environment, really. If you haven't got your servers configured for SQL authentication and such like, it's an interesting one, and again, it's a bit of an it depends. But I would strongly avoid using SA as the database owner.
What is instant file initialization?
Instant file initialization is a mechanism. Now, when you create the files for the database, the data files themselves, if you've not got instant file initialization on, it essentially writes, if you grow it by 10 gigs, it will write 10 gigs to the disk. If you've got instant file initialization on essentially what it does is it just moves the pointer for the end of the file and says, actually, the file is now 10 gigs bigger than it was, without actually writing all of that data down. Now, that only applies to SQL Server data files. It doesn't apply to transaction log files. They have to be zeroed out so that SQL Server knows what state they're in, essentially. So if you do it for data files, it means that you just write the data down as it eats its way through the file quite happily.
What do you recommend to take performance baselines and how often?
I've got a vested interest in saying SQL Sentry. We've got great baselining, but obviously if you want free tools, Perfmon and PAL. PAL is, I think PAL's on Coplex as well, pal.coplex.com. If you do a Perfmon capture to a BLG file, binary log file, PAL, you can actually do an analysis of it, performance analysis of logs. Very, very useful tool. You can automate the collection of the Perfmon collector sets using things like PowerShell and scheduled tasks. And I do it as often as required. So if you've got a key process, for example, an overnight batch load, I would run Perfmon to capture that and maybe do it weekly, maybe do it monthly. Depends on what your workload's like. If that workload is very static and it does the same thing week in, week out, and maybe every quarter you increase the amount of data, things like that. Just have a look at what you're doing and understand your workload as well. But yeah, Perfmon and PAL are a good sort of mechanism for getting raw baselines, although it does require a little bit of manual work and scripting.
Does separation of the MDF, LDF, and Temp DB really matter with full SSD storage subsystems?
Like I say, from a performance perspective, that's less of an issue than it used to be. It just comes down to how easy it is for you to manage the volumes on what they're stored. So, for example, if you're running a Hyper-V server and you've got your VHDXs, you might just want to create them so that you've got the ability to move for example, you want to say, I'm going to take Temp DB and I'm going to put it over on this bit of the SSD storage system, or I'm going to put it somewhere else, or I'm going to bring it local, stuff like that. It's just, from a management perspective, it can help. So it also means that you're not just pushing everything into a single huge virtual file or a single huge LUN. It just, whatever's easier to manage in that scenario, really, for you.
What are your thoughts on linked servers?
I'm not a huge fan. I try to avoid them where I can. Obviously, if you want to use things like StretchDB in 2016, that's going to necessitate a linked server in the background to connect to Azure. But when it comes to architecting systems like that, I would much rather do a lot of the joining everything together up in the app tier. I'm a big fan of service-oriented architecture, microservices, and stuff like that. And that way, the database components essentially become very small, discrete units that you interact with, and it gives you the ability to move them around and decouple them. Linked servers, they can be a real pain. If you've got queries that span off to 4 or 5 servers through linked servers, again, thinking about the overall performance and performance tuning side of it, you just see a lot of the time it's got a remote query, so you lose a lot of that visibility as well when it comes to performance tuning. So yes, sometimes they're a necessity. They can be useful for doing quick and dirty things, like I need to pull some data across and I haven't got integration services to hand, or something like that, and it's a one-time operation. But overall, I'm not a huge fan. I would try to architect something in that doesn't need that.
How do you create a low privilege account?
Just create an account that's a member of public, so don't give any rights, that type of thing.
Okay, an observation that PAL does not work for SQL 2014 and upwards.
It might not have a built-in threshold file and stuff like that, but there's nothing to stop you creating one. I've used it on 2014 binary log files before and not had a problem.
Can you use a managed service account for SQL Agent?
Yes, so long as it's SQL Server 2012 and above.
What about database chaining?
Again, it's not something I'm a huge fan of. Like I say, when it comes to building systems, I don't like cross-database queries. I don't like linked servers. I like designing very decoupled systems because it means that I've got more versatility to move things around. So that would be my view on when you try to design SQL Server and data systems, decouple them as much as possible. Database chaining is not something that I would typically turn on by default.
Nor would I. Check DB for log data increases Temp DB dramatically. Do you have a recommendation on the appropriate size of Temp DB for this?
It will really depend on what size of data you're working with. And when I've got queries or questions around that, I tend to always go to Paul Randall's blog. I would say if you're going to find a good source of information that's going to help you make that call about what you need to set your environment to, I would look at Paul Randall's blog and a lot of the extensive writing he's done on CheckDB.
And this one could keep you busy for the rest of the week. What are the issues with XP Command Shell? Why is it discouraged so much?
It's really a case of my viewpoint. I've seen systems, like I said, configured where SQL Server has been configured as a domain admin, and in those scenarios, it is possible to jump out to the command line with domain admin privileges. That's not going to be a great scenario. Rob Volk has got some very interesting demos that I think he's trying to work into some presentations around some of those sides of things, and it's just interacting with the command line in that way through T-SQL. Again, it's close coupling to another subsystem that's potentially better served by doing it another way. In agent jobs, in integration services, something's designed for interacting with that external processes, the file system, and potentially Active Directory, anything like that where you've got that command shell. PowerShell, again, is really coming to the fore and can make life a whole lot easier. So if you can architect a solution that uses PowerShell, you'll be in a stronger position. There's a lot of risks potentially around using XP Command Shell, depending on your configuration and what you're using it for, and the privileges you've had to grant. So, for example, if you're picking up and moving files, potentially it's extra privileges for the account that's running SQL Server, things like that. So there's any number of potential issues out there. It just depends on exactly what you're doing with it.
Okay, that is the end of our questions. Thank you very much, John. And you're going to send me your PowerPoint and all the stuff you mentioned so I can post it.
Yep, not a problem. I'll get that done for you.
I'll send you the stuff we talked about earlier as well as the questions log, so you'll have it as a record. And
much appreciated.
So thank you all very much for coming. Next meeting, I believe, is April 14th, although I'm having a little trouble. April 13th. And I can't remember who the speaker is, but I'm sure it'll be interesting. Thank you all very much, and I'm going to end the webinar. And